Hi, welcome back to my channel. My name is Gina. In this video, we're going to revisit limits and talk about L'Hopital's rule. L'Hopital's rule is a really useful rule when you have indeterminate limits. So first, let's do a quick recap on limits. If you want to review the video on limits, I will also put the link up there. The easiest way to find the limit of a function is to use the cheating rule, meaning we substitute the x into the function. However, if you want to find the limit of a function that is in fractional form, f of x over g of x, then when you use the cheating rule, you can get three different outcomes. The first one, L, any real number, over n, a non-zero number. Then the limit of f of x over g of x as x approaches a is simply L over n. However, if the denominator equals to 0 and the numerator is a non-zero number L, then the limit does not exist, which also means that the limit will go to either positive or negative infinity. So at x equals to a, you have a vertical asymptote. In the third case, when you use the cheating rule and you get 0 over 0, then in this case, cheating rule does not help. So it's inconclusive. So in this video, we're going to talk about this type of limits. When you use the cheating rule and you get 0 over 0. And we call this type of limits indeterminate limits. So L'Hopital's rule states that if limit of f of x equals to 0 and limit of g of x equals to 0, or limit of f of x is either positive or negative infinity, and limit of g of x is also a positive or negative infinity. In other words, if the function is of the form f of x over g of x, then when you use the cheating rule, you'll get 0 over 0 or infinity over infinity. So L'Hopital's rule states that if you get this type of limits, then limit of f of x over g of x equals to limit of derivative of f of x over derivative of g of x. And a quick note, I said limit of f of x and limit of g of x. And this limit can be a regular limit, or left-sided limit, or right-sided limit, or even limit at infinity. Now let's look at some examples. First one, limit of x squared minus 4 over x minus 2 as x approaches 2. So first thing, we always need to try the cheating rule first and to see whether this limit is indeterminate type. So if we substitute 2 to the function, we'll get 4 minus 4 over 2 minus 2, which is 0 over 0. So we have an indeterminate type. And in the first video when I talk about limits, I said when we have this type of limit, then we'll go back to algebra and try to simplify or expand the function. So let's try that method first. So this equals to limit as x approaches 2. The numerator is x squared minus 4, and we can expand that to x plus 2 times x minus 2, and the denominator is x minus 2. So the x minus 2 in the numerator can cancel out with the x minus 2 in the denominator. Now let's try the cheating rule again. We have limit of x plus 2 as x approaches 2. So we substitute 2 to the x, so we get 2 plus 2, which equals to 4. Now let's try to use L'Hopital's rule. So L'Hopital's rule says if we use the cheating rule and get 0 over 0 or infinity over infinity, then we take the derivative of the numerator and denominator. So this equals to limit as x approaches 2, then the derivative of x squared minus 4 is 2x. And the denominator is x minus 2, and its derivative is 1. So this equals to limit as x approaches 2 of 2x. Now let's use the cheating rule. We substitute x by 2, and we get 2 times 2, which equals to 4, which is the same as what we have found. Now let's look at the second example. We have limit of sine of x squared over x squared as x approaches 0. First, as usual, we always need to try the chain rule first. Sine of 0 is 0, so the numerator is 0 squared over x squared as x approaches 0, so the denominator is also 0 squared. So this again we get the type of 0 over 0. However, in this example, algebra doesn't help. Unlike the first example, we can expand the differences of squares. So here the only choice is to use L'Hopital's rule. So this equals to limit as x approaches 0. Now let's take the derivative of the numerator. So we have sine x squared, which is an inside function sine of x squared. So we need to use the chain rule version of the power rule. So the derivative of the numerator is 2 times sine of x times derivative of sine of x, which is cosine of x. And the derivative of the denominator is 2x. And this 2 can cancel out with the 2 in the denominator. Now let's try the chaining rule again. In the numerator, we have sine of x times cosine of x. And when we substitute x by 0, we get sine of 0, which is 0, times cosine of 0, which is 1, over x as x approaches 0. And again, we still get the form of 0 over 0. So now let's use the L'Hopital's rule again. This equals to limit as x approaches 0. Now we need to take the derivative of sine of x times cosine of x. So here we'll use the product rule. Cosine of x, which is derivative of sine of x, times the second function cosine of x, plus the first function sine of x times the derivative of cosine of x, which is negative sine of x, over derivative of x is 1. Now let's use the chaining rule again. Cosine of 0 is 1, so we get 1 squared minus sine of 0 squared, which is 0, over 1. So this limit equals to 1. Now let's look at the last example. Here we have limit of e to the power of x squared over x cubed as x approaches infinity. Let's try the chaining rule to see whether this limit is indeterminate. So we substitute x by infinity and we get e to the power of infinity over infinity. So this we get the type of infinity over infinity, which is an indeterminate type. So we need to use L'Hopital's rule. So this equals to limit as x approaches infinity. The derivative of numerator is e to the power of x squared times derivative of x squared, which is 2x, over derivative of x cubed, which is 3x squared. The x in the numerator can cancel out with the x in the x squared in the denominator. And if we cheat again, we'll still get infinity over infinity. So let's use L'Hopital's rule again. This equals to limit as x approaches infinity of the derivative of numerator over derivative of the denominator, which equals to 2 times e to the power of x squared times 2x over 3. And if we use the chaining rule again, you'll get e to the power of infinity, which is infinity, times another infinity. So this limit equals to positive infinity. That is the end of the video. If you want more examples or you want to know how to solve the other type of indeterminate limits, I have an online course on Calculus 1, and I'll put the link down below, and you can enroll in the course. In the course, I explain everything you need to know in Calculus 1, including 9 assignments with solutions. I hope this video helps you, and I'll see you in the next video.